we got your mail in our official mail ID.
Yeah, I sent to all of to the personal mail ID only, the link. I have your mail IDs, no personal mail IDs. Can you check it with your friends or somebody whether they want to come, or can I start?
Sir, I'll text in the group and let you know.
Yeah, yeah, do it. My screen is visible. Anybody let you know?
Yes, sir, it's visible.
Yeah. Okay, anyhow, I will start now. 18 members are there. I will see that there is HVDC transmission when this is important subject, and also very small syllabus when compared to any other subject, but it is technically very useful, and we should know what is the HVDC transmission, why we go for this, what are the control strategies, protection, all these things we'll cover here. But the thing is, as per HVDC is concerned, normally so far we have AC transmission, but nowadays that is changes to DC, and also another advantage is for many appliances nowadays they are using directly DC. Then why we go for as a AC? That is the scenario. but all generating stations are all AC, but we should convert it into DC and you can utilize, or even solar and all the things are available in DC also. We can use directly from that because appliances are in DC. These are the things we need to discuss in this course, but course consists of as usual of 5 modules, but very simple, and it is a more or less understanding way and general way. And the thing is, one unit is there, I think second unit, there is a lot of analysis is there, like what we discussed in case of power electronics. There is a controller, phase control rectifier. There we know what is the rectification mode and inversion mode of operation. All the things will in detail or in depth will be there in that particular unit, preferably in case of rectification mode and inversion mode of operation. Now we need that. That's the reason I mentioned in the power electronics case also. There is a alpha less than 90 and alpha greater than 90 concept that will come back here. And one topic we discussed there, effect of source inductance. Because of that effect of source inductance, what will happen is, in general, when you are not considering as a source inductance, instantaneously devices is going to be changeover. That means from let assume that 1 and 2 device is conducting, then at pi or pi plus alpha or at beta, instantaneously 3-4 device will conduct, suppose if it is a single phase. Similarly, when you consider as a source effect, what will happen? Incoming device and outgoing device together will fire some duration. That we call it as a overlap angle. So that case is a very sensitive parameter in this HVDC transmission. Here I call it as a valve. Valve is nothing but here as a device only, like thyristor. We use to hold this as a thyristor only because control circuit. Here is a power station that consisting of a rectification as well as inversion. Both we need as a thyristor. So in the common notation we call it as a valve. Valve 1, 2, 3 and so on. Then if overlap takes place, what will happen? The valve effect. So all the things will come across in this. So that is very important. That itself as a one big course. If you consider 3 valve and 4 valve, so overlap angle less than 60 degrees, greater than 60 degrees or equal to 60 degrees. So all these analysis will come into the picture. So now we'll see the briefly, these are all introduction only. We'll see what are the topics going to cover, and then what are the books need to prefer for reference only. And even my presentation itself is sufficient for your reference for exam point of view, but still you can go through some of the books. It is like KR Padiyar, that is the very good book, and Kamakshaya is another book. So like that, very few books only there, but you can able to refer my material as well as these books. And now we can see that HVDC transmission is in our course, and there is a myself I will discuss this on 5 units. One is the general consideration of DC and AC transmission system. These are all about theoretical part only. Just like what is the introduction and then advantages, disadvantages, comparisons, all these things that will come under this unit. And general consideration of DC as well as the AC transmission systems. So that is one thing. And another one, second unit, you can see that there is a converter circuits. So now this is very familiar all of you. Once if you are aware of power electronics, you come to know that same thing. I think one more different is there here. In case of power electronics, up to 6 pulse converter we discuss. Here if you in general we will go for as a 12 pulse converter, but analysis all the things are 6 pulse only. But In high rating, power rating, we will deal with this. That's why generally we will prefer as a 12 pulse converter. Two 6 pulse converters connected in series to form as a 12 pulse converter. So this one is the another unit. All controllers, rectification mode, inversion mode of operation, derivation, and then we need to plot wall voltages, average output voltages, if overlap angle is equal to something, because here all waveforms will differ with respect to the overlap angle and firing angle. So here consideration is a overlap angle that must be
Sir,
there.
it is in first slide only, sir.
Oh, okay, okay. I will share on. Now it is visible.
Yes,
First
sir.
slide. It is moving. Check it.
Yes.
Second slide.
Yes, sir.
Yeah. Okay. Fine. And so these are the just units titles. General consideration of DC and AC transmission systems, and then converter circuits. Then there is a that's what I told. No, the converter circuit is a big role in this. All the HVDC transmission we required this. In general, there is a two stations are there. One is a sending end, another one is a that receiving end side. There is another station, because the why the two things are required. As you are aware of that, what we call it as in HVDC transmission, generally AC is available, and this AC we have to connect it to the transformer to just step up the voltage. Then we need to connect one controller, means one station, that we call it as a rectification station, and then we'll get it as a transmission. And then we can use as a inverter station. It will convert something DC to AC, and again we have to use the transformer, and it will get it as a sending it, final load side. So these are the general scenario, just as a black diagram. There is a source, then you have to use step up transformer, and then we use the rectification station. Then these are all transmission line. There is a DC transmission line, and then you have to convert the DC into AC. We are using an inverter station. That's the reason we call it as a, this is a R, and this one is a I, rectification station, and then inverter station. And again we'll come to that step down the voltages, and it goes to the distribution side. All these things will happen, and that will be as a simple diagram of HVDC. And now the control strategies we will discuss on the third unit. And the fourth unit is a protection. All the things we need to use protection, even for thyristor case also we are using as a protection. Snubber protection means dv by dt, ti by dt, like that. Lot of protection is there for HVDC transmission also, that we'll discuss under fourth unit. And final one is a multi-terminal DC systems, so that is the fifth unit. Now we'll see the in detail syllabus of each unit. We may have something, there is a reference books, I told, no, KR Padiyar, and then Kamakshaya HVDC transmission, and this Arilaga also there, very good book, this one, flexible power transmission in the DC optional. So there is a, some of the books. I will share you the soft copy of the text books also. But it is there in library, many volumes. Just a minute.
సరే అది కీర్తన దగ్గర
All of
ఉన్నది
you mute, ma. Shushmita.
దాన్ని అడుగు అవి చూడడానికి.
Yeah. So what we want to do is just refer text books. It is there in library, and We'll see this. These are the listed books mentioned, but some more books also there. You just go through that. But I will share these soft copies of these books, all of you. And now there is a first unit, general consideration and DC transmission system, that will be dividing as a subtopics. Comparison of AC and DC transmission, that is the one major topic. That will come under again three subtopics will be there, that is economics of power transmission and technical performance and reliability. So these are the major three topics going to be covered. And the application of DC transmission, that is another topic. Next one is a description of DC transmission system, that is the types of DC links, so and converter stations. So there is a preferably we have three DC links. Anyhow, I will come to that part after syllabus coverage of a small thing. And there is another types of DC links, and then planning for HVDC transmission, then modern trends in HVDC technology, because what is the latest advanced technologies are used in HVDC transmission and all, that will cover there. Voltage source converters only we are using in this HVDC transmission, so that all under this. And there is some corona losses when compared to the AC DC, corona losses are very negligible or very less. We'll see that aspect also. These are about general consideration of DC and AC transmission system. So here more or less only 2 to 3 questions in that. One thing is comparison of AC and DC transmission. If that is a essay question, what you want to explain is all the three aspects we need to explain. One is economics wise, and then what way it is superior, whether DC transmission is superior or AC transmission is superior. So all these things will come under this economics of power transmission. That preferably based on the distance we can decide whether AC is a preferable one or a DC is a preferable one. For the low distances, generally AC transmission is cheaper, but for long distance and bulk powers, preferably will use as a DC transmission. So that is the economics of power transmission will come under that part. So there is some break-even distance which they will mention up to, let it be as a 500 kilometers to 800 kilometers. So beyond that, we can see that DC transmission is a preferable one when compared to the AC transmission. So all these things, why I mentioned that distance aspect, when you want to transmit the AC power for long distances, that to bulk powers, as you are aware that in general notation, all these things introduction only, anyhow will come back once again. As you are aware that AC transmission we required as a 3 transmission lines, big towers or insulators, all these things we need to concentrate, and then right of way, I mean area or land, you can say that to erect that plant, what we call it as transmission lines, we required as a huge area also. But once if it is a long distances, then what will happen, AC transmission is not a preferable one, because that much copper is wasting the transmit the power. But whereas if you go to the DC transmission, as you are aware that how many conductors are required for DC transmission, anybody? When compared to AC, I'm telling, in AC transmission, I think you observed that RYB is there, earth wire, neutral wire, so all the things are there. But once if you come down to the DC level, means DC transmission, then what will happen, you can see that we need only how many conductors in DC? Anybody? Any answer from your side? DC transmission, how many conductors are required?
2, sir. 1.
Yeah, even some cases 1 is sufficient. So that much saving is there. Instead of using that many conductors in a DC, we can observe that I mean AC side we are using more number of conductors, but if you are using as a DC, it is preferably 2, but Some cases we may be required only one conductor also sufficient. The return path, there is another conductor for the return path you can use as earth or a sea water. So that thing we can use, so that lot of copper is going to be saved. So then initially I mentioned one statement for low distances or less than 500 and all, AC is preferable one, because if we are not able to transmit the power very long distances and not a big power, means huge power we are not able to transmit, but if you are using as a DC, initial cost of the DC transmission is a high. That is the major issue here. Why initial cost of a transmission is a transmission cost is a high in case of a DC. Reason is whether you want to transmit long distances or not, but the equipment what you are using to transmit that will be the same. Only the thing is one conductor length will differ based on your distance, but other than that all the equipments are same. Whether if I transmit to 100 kilometers or 1000 kilometers, the stations are same. Sending end station we need to install, means the rectifier station, and then another one is a inverter station. So both is required. That is the reason for the low distances, preferably cost of the DC transmission is high, but AC transmission cost is little bit less comparatively. But if we go on increasing the distances, then what will happen if I use a AC transmission for long distances? What will happen? So all the way we need to erect that all the RYB faces, and then big towers, that is a lines towers we need to install. We required as a lot of area. So all these problems consider, then the AC transmission cost is very high. If it is beyond 500 to 800 kilometer range, in that is a break even distance, they call it as a below that range we can see that AC is preferable one. Beyond that preferably DC is a cheaper. So that is the what economic consideration, that's one of the comparison. And then technical performance is the another aspect. We can see that technical performance, how the system is going to be perform with compared to the AC, and why it is a preferable one. Like a stability limits, you can say that in this case of DC line, you can see that full control over the power transmitted. That means ability to enhance the transmitter, and then small signal stability. So in the AC network, fast control to limit the fault current in a DC line. So all these aspects, and then we can see that stability limits also one of the aspect. Only just briefly I am highlighting that point, but not going in depth. That will cover in the first unit anyhow. Then voltage control, you can see that as you are aware that surge impedance loading, all these aspects will come into the picture. So if that loading is equal to the surge impedance or greater than or less than, based on that what will happen the curve in the distribution side. So voltage control and line compensation. In AC cable transmission, it is necessary to provide the shunt compensation at a regular interval. So that's what in the long transmission lines and all we can notice that in the diagrammatically also. That is a line compensation problem. There is a problems of AC interconnection. We can observe that one major issue in case of AC transmission, in a power system, you can see that AC tie line. You suppose I want to synchronize the two sources. What we need to consider, that frequency must be matched, voltage must be matched. So all these things we need to consider. Suppose balanced system and unbalanced system you want to synchronize. So there is a problem with AC. But once if you are using as a DC transmission, whatever may be the system, you are converting that system into DC. Then no matter of frequency, directly we can able to interconnect. That is the issue is available in a AC transmission, problems of AC interconnection. That is a large power oscillations which can lead to frequency tripping in case of AC. Suppose is there any power oscillations, the frequency oscillations, and then automatically there is a tripping system is going to be tripping, and then fault levels also will increase. So all these aspects will preferably DC is a superior, and then ground impedance also there. In AC transmission you can observe that existence of a ground, that is a zero sequence currents cannot be permitted in the steady state due to the high magnitude of the ground impedance. All these aspects we can see that we'll going to discuss. And even though whatever we know explaining in the superior aspect of what you call it as DC, but some of the disadvantages also there in a DC transmission system. Anybody can speak out some of the disadvantages when compared to, these are all general discussion. I freely just discuss, because everybody know that AC transmission so far, but we know that DC means there is a battery or some solar, but a huge amount of power in throughout the world. A lot of DC transmission system is established. I will show you some of the names or just diagrams. But now, what is the drawback? By with this introduction, what you can say that drawbacks of a DC transmission, anybody? Each one can speak out at least one drawback. Anyone? What is the drawback of, I'm not asking advantages, many advantages are there anyhow, but what is the disadvantages I'm asking? When you can see that in AC, suppose there is a one small comparison, forget about this AC and DC transmission. There is a rectifier and then chopper. Let's consider one small thing. From that you will get one disadvantage. In a rectifier, what type of commutation will be used? Which commutation is used in a rectifier? Anybody? Natural or forced commutation?
Natural combination.
Yeah. So in a rectifier, natural commutation. Why? Because there is a input is AC supply that going to be naturally zero. Maybe depends on your load. It may be pi or a beta or pi plus alpha, whatever may be the scenario. But you come to the DC. What will happen? There is a forced commutation. So why it is a forced commutation? Because input is a DC, it won't go to natural zero. That is the aspect there. One drawback I can say that the commutation is a problem there in case of a chopper. We need to turn off the device forcibly by make use of the additional commutating elements like L and C. That is the aspect of rectifier and an inverter. Like in this scenario, in case of AC and DC transmission case, so what will happen? DC current cannot be breakable one. So that is a very high cost of DC breakers we need to use. Whereas in case of AC transmission, we can see that circuit breakers are simple in nature, but anyhow that naturally it goes to the zero, and zero instant will be occur. But even middle you want to turn off, we can able to use that circuit breaker and all. But when comparatively AC, DC circuit breakers are very costly, because it is we need a lot of protection that will not go to natural zero. Whatever current is transmitted in a line, and that much current will be there, and you have to quench that current. So that is a limited by that current. So there is a sum of the aspect we need to consider for designing of a DC circuit breaker. So that is a costly when comparatively AC circuit breakers. So another one we can see that we cannot use transformer in this case. Whereas in case of AC transmission, we are using as a transformer. Why we are using transformer? In AC transmission,
Step up or step down the voltage.
yeah, that is our requirement, because you can see that we are not using the constant voltage levels in the industry or in houses or colleges or something different. Load points are there when comparatively other aspect in case of AC, houses 230 they will use, or 440 they may be used 3-phase supply, or maybe in 11 kV some industry will take and somebody will take 33 kV. So it depends on your requirement. We will select as a transmission line. Suppose you want to feed power for low voltage side, we cannot feed much power, preferably beyond 11 kV and 33 kV only we can able to feed power through solar or whatever means. Somebody private vendor is installed as a some power plant that consider as 1 megawatt power plant. He will generate some power. He want to feed power to the lines only because he cannot consume that much power. Whatever plant is generating the power, that power has to be sent through the lines. So to send somewhere we need to feed. There is a lines will be there in substation, at least minimum 33 kV or 11 kV line is minimum 11 kV line is required to feed your power. So that power is transmitted. That's what wheeling charges they are charging the government lines. If any private consumer want to transmit the power from here to something Chhattisgarh or some other state, you want to transmit the power, you cannot install the some other lines because everybody cannot install the transmission line. That is very costly manner, and then a lot of issues with the land acquisition, all this problem. That's why generally what they will do is all these private vendor, because nowadays like different vendors are there in the power sector also. In suppose Mumbai and all, you cannot buy the power only to the electricity board. If you want separate like mobile phone networks, they can use as a Vodafone or something, Airtel or some Reliance. So whatever you are preferable or willing to buy, you can buy. Like that, power also depends on your interest, bare quality of the power. You can choose your provider. So like Reliance power will be there, the Tata power will be there, and government power will be there. Like that, many generating vendors are there. So what they will do is each and everyone cannot install as a transmission line. Simply they will generate the power and will take the permission from the government lines. We have to take that net metering concept there, and we have to feed power the particular instant where the power plant is installed. There we have to install one transformer. The line has to taken from 11 kV, because if it is a big power plant, you have to take it as a 33 kV line. Nearest to the 33 kV line, you have to transmit your power and you have to feed there. So like that, for that when you are charging, you are using their equipment, you have to charge the wheeling charges. This much wheeling charge, something they will decide that vendor to that particular vendor. So like that, we have to transmit all these things. So that is a, there is a transformer issues will be there in this case. You cannot transmit, you cannot step up the voltage or step down the voltage. Whatever you want to do, once the generating plant is there, you have to use the transformer. After that, you have to convert it into DC. Once it is converted into DC, you cannot change that voltage level, and you have to transmit completely from that sending end to the receiving end side, and there again you have to convert it into DC to AC by make use of a inverter station. So that is another substation is required. Here only the two substations, one is a rectification station, another one is an inverter station. So that is what another issue will be there. So the conversion equipment, the third one, you can see that conversion equipment also is a problematic. What is that conversion equipment? What we are doing as a rectifier station. Rectifier station means it is not a simple like a fully controlled rectifier, something like that. There is a 12 pulse converters will be there. Each wall, it is a huge amount of power carrying capability. That rating of the device is also very high, and one thyristor is not sufficient for the circuit. Suppose if we consider 6 pulse converter, how many devices are there? Anybody? 6 pulse converter, how many thyristors are required? There is a 6 thyristors are required. But when you are using as a 12 pulse converter, another 6 pulse converter connected into series. But now Here once if you are using as a this converter in a transmission side, what they will do is that is not a 6 devices actually. There is a 6 unit will be there, that is a wall that each thyristor connected in terms of the series and parallel they form as a string. So that means to carry capability, current carrying capability will be increased by connecting the number of SCRs are in series and parallel for the voltage rating as well as the current rating. For higher voltage purpose we are using as a series operation. For higher current purpose you can use as a parallel operation. So like that many number of devices are incorporated in that the substation side, whether it is a rectifier station or a converter station. That is the problem in this conversion equipment is a very high cost. And another major issue also will be there, harmonics. In case of AC as well as the DC filters we need to use, whether it is AC, one side is AC is connecting, another side it is converting as the DC, and again another station DC to AC. So for everybody knows that once we are using as a power electronics controllers, that impact will be there, harmonics. So the lot of harmonics will be injected in the source side as well as the load side. Therefore AC and DC filters are required. Not only the AC, here AC as well as the DC filters are required. So in addition to the cost of the converter, so cost of the converter is high as well as we required as a filters. Even in normal case also filters are required, but here both filters are required, AC as well as the DC. So another as you know that control thing is a complex one. So whether you want to control the power, it is a complex one. So now that's what one of the topic we mentioned here is a modern trends what we discussed in that previous thing, just subtopic of that. What will happen is because of the development you can see that DC circuit breakers are developed, a lot of DC circuit breakers are now implemented because it is a lot of technology has improved in that case. So therefore now it's somewhat we can able to use that. So there is a modular construction of thyristor walls, that is a failure of walls are very less. So all these some of the now 12 pulse converter operation also come into the picture, and these are the some of the things. So all the things is going to be covered in this unit. So these are all purely theoretical oriented in this unit. So what are the comparisons and comparisons, another last topic technical is second one, and third one is the reliability aspect also. So how reliable it is when comparatively AC. And there is a DC transmission is very good when compared to the AC in terms of the reliability aspect. Why I call it as a reliability aspect, the component failures are very less. Some of the components you can say that thyristors and all, with the literature I am telling, even 13 years and 14 years you can see that that many years it is going to be work without failure. Many they tested DC filters, they tested AC filters, they tested existing plants. I'm telling from the existing plants they quoted some of the things in the literature. They mentioned that failures in the component 7 years and 11 years and 13 years, something like that. AC filters they quoted 12.6 years, DC filters 19.7 years, reactor, so smoothing reactor and all they are using. That is one of the topic anyhow. Smoothing reactor in the sense whatever we are converting that we are passing through the reactor so that it will nullify some of the higher order harmonic. It is very low magnitude so that inductor is sufficient to smooth out that. So that reactor and all 76 years also it is working. So that much reliability will be more when comparatively that. And another topic we mentioned here, applications. Applications of a HVDC transmission. So with this, once the application, you can say that where we'll use this HVDC transmission, preferably long distances and bulk powers. I already mentioned you for small distances, AC is preferable one because initial cost is very high in the DC transmission. That's why only it will be used for long distances and bulk power. It is a major application. And another thing, suppose I want to transmit the power, underground or underwater thing, AC cannot be preferable one. So because there is one conductor there, using a return path itself as a seawater or a ground they can consider, and for submarines and all, they can use only the DC cables. That's what underground or underwater cables they can prefer. And another third point you can remember, one thing I mentioned in the earlier sentences, whenever you want to synchronize that systems, AC systems in the different frequencies, that cannot be synchronized through AC. Suppose Indian system and the American system want to synchronize. It is not at all possible. They have 60 Hz frequency. We have only something like 50 Hz frequency. So you cannot directly tie in that. What they will do, they you have to change that frequency or make it that frequency levels to the same. Then only you can synchronize. But whereas in DC side, they will convert there in the power to the DC, and here also they will convert it into DC and they can synchronize it. So for these type of requirement, means the issues will arise, then we'll preferably go for as a DC transmission when compared to the AC transmission. So these are the some of the application. In broadly I am speaking some of the application. And then there is a types also I mentioned, links. What are the types of DC links? This is the another topic in this. What are the DC links are available? There is a preferably we have 3 DC links. That is a monopolar link, and then bipolar link, homopolar link. So these are the names we call it as a the different links. They may be used in the different areas. They already established and they're running, but depends on their capability they will prefer. And monopolar link is nothing but only one conductor. I mentioned preferably DC is a 2 conductors are required for the transmission, whether it is in the what you call it as positive and negative. But some cases one conductor also sufficient to transmit, that is a monopolar link, positive or a negative. Any one conductor is sufficient, but preferably negative polarity will be used. So and ground is a return path, so that we can consider as a metallic return also sometimes they may be used. So that is a one type of a conductor. Anyhow, that will come under with the diagrams. All these things will come in the first unit. That is a monopolar link. Another one is a bipolar link. So it has 2 conductors. Bipolar link is we have 2 conductors. One is a positive, another one is a negative. So there is a bounded conductors they will use in extra high voltage lines and all. So this is the one type of link, that is a bipolar. Bipolar means that plus and minus both conductors will be there. Bidirectional power flow also possible. And third one is a homopolar link. So it has 2 or more conductors. That is the same polarity. Preferably we'll use as a negative polarity. There is usually we'll use that. And then return path you can use as a metallic or a ground or a seawater, all these things. So these are the some of the types of a DC links. 3 DC links will be there. And later after discussing that converter station, any of the converter, whether it is a rectifier station and inverter station, both is same. Why it is same? Anybody? The rectifier station or inverter station, both is exactly same. We cannot change anything in the component side or whatever it means. Why it will be the same? Anybody? The rectifier station or inverter station is same. The reason is we are using here is a line commutated inverters. So that means same phase control rectifier can act as a rectifier or can act as a inverter. At what conditions? What is the thing we need to do to convert rectifier into inverter or inverter to the rectifier? What we have to do there?
Sir, firing angle.
That is the scenario. because all the phase control rectifiers only we are using. But when what we discussed in power electronics, that controller only, but only the thing is lot of components are connected in series and parallel to form as one device itself, because it has to carry more amount of current, is large power distribution side we are using. That's why what I am telling is any station, the bidirectional, it is a bidirectional power flow is possible. Suppose the first one, let I call it as a sending end is a rectifier and receiving end is inverter, but bidirectional also possible. There you can, in the receiving end you can change it to alpha less than 90 degree, it becomes as a rectifier, and the sending end side you make it as alpha greater than 90 degree, it becomes as inverter. Therefore power flows from sending and receiving end to the sending end. That's what control strategies, all the scenario and equipment. Here a lot of equipment will be there, because there is a protection also will be required. DC filters is required and tuned AC filters also required. So like that there is a reactors will be there. And then input side, suppose the station we need to use as a transformers, because the 12 pulse converter we are using in generally in HVDC transmission. So there is a 2 6 pulse converter connected in series, therefore we have to use as a transformer connection also. There is a star star connection and star delta connection will be used for the first 6 pulse converter. Star star will be used, and second one is a star delta. I will show you why that will be change is required and phase shift is required. So all these phenomena will covered in this unit, that is a converter stations. What are the components will be there in the converter station, and briefly will explain each component like a smoothing reactor and DC switch gear and filters and then transformers. So all these things will covered in this unit. Another one is a planning for HVDC transmission. So what is the planning here? Normally we can see that there is a DC system is alternate with that of the transmission when we compare to the AC. So DC is nowadays now preferable one. So what we need to consider is cost aspect. So that is the first one. We need to plan such a way that cost of the transmission must be as a minimum. That is the one of the major issue in that you have to consider. That is one factor. And technical performance also you have to consider, reliability aspect. So with the consideration of all these, we have to design these planning of HVDC transmission by considering of these three factors. That's what I mentioned in the comparison case also. So plan such a way that, and then choice of voltage levels, and what are the voltage levels we have to consider in this transmission system, and all these aspects. Then modern trends in HVDC transmission technology. So what is the modern trends is olden days we can see that before thyristor what we are using, before thyristor what is the thing is available. Yeah, that is the power semiconductor devices technology. Before that there is a mercury arc valves. So all these things will be used. There is a failure will be more in that aspect. That is not a much reliable one. That is the reason power semiconductors and valves are developed as a huge in the research area. In that aspect there is a lot of voltage rating and current ratings in that valves. So valve is nothing but here is a thyristor you can say. There is a valve rated even 125 kV each device can withstand, and then 3 kiloamperes up to 3 kiloamperes also it can withstand in the current aspect. So all these phenomena we have to explain the modern trends, how the device is going to be developed in the valve aspect, and then converter control strategy aspect. And converter control strategy, you can remember one thing what we discussed in the power electronics. There is a, in a power electronics you can see that how the controller is going to be, I mean phase control rectifier is going to be controlled in a power electronics. Anybody, how the voltage is going to be varied? Phase control rectifier, how the voltage is going to be varied? Anybody? In a phase control rectifier there is a firing angle. How the firing angle going to be vary? We have a lot of mechanism. One is R triggering, RC triggering, UJT triggering, the synchronized ramp triggering, all this. So what it means is the development. Preferably nowadays they don't use R triggering or RC triggering or UJT triggering. There is a microcontroller based firing pulse generation is there. You are writing a code and then you are generating a pulse, and that code has to be inserted in a chip. That chip will be used automatically, pulse is going to be generated. So that is a lossless, so very without using any any components like R triggering or RC triggering. Usually a lot of components need to use to generate as a firing pulse. But now we are using as a microcontroller. So our laser, one of the firing method is there in the SCR. I told no lasers. There itself I mentioned it will be used in HVDC transmission and all. So like a sharp technology is developed. That all the things is going to be discussed in this modern trends in a. That is one of the topic is there in your syllabus, modern trends in HVDC technology. In that how the DC breakers are developed. Now olden days and nowadays there is a development and testing of prototype DC circuit breakers also available. So all these things are very important developments are there that you have to explain. Existing AC lines, how we have to improve that existing AC lines are converting into the DC form, and active DC filters you have to explain. Ultra high voltage DC transmission, that is a plus or minus 800 kV transmission lines, even 1500 kilometers. In China and India, South Korea, there is a some of the places they already installed HVDC transmission. I will show that globally where the HVDC transmission systems are there. So all these if you explain in the scenario, so that will come under as a first unit. So this is a very simple thing. Only the comparisons, advantages, disadvantages, applications and type of link, that is a homopolar, bipolar, monopolar. So this these are the different types of links, and planning, and then modern trends. That's what I mentioned all the syllabus here. Planning of HVDC transmission, and then modern trends, HVDC transmission, and corona losses. There is a how the effect will be there in the DC transmission, but it will be there only in the AC transmission much, but DC transmission is very less when comparatively AC. So all this will come under as a first unit. So this is the brief introduction about the first unit. Now another one you can see that second one, converter circuit. So here converter means that you just remember one thing, it is a line commutated only. Whatever converter we are using, whether it is in the HVDC side, rectifier station or a inverter station, we are using as a line commutated rectifier or line commutation only. There is analysis of grid circuit. There is a grid circuit in the sense like a 6 pulse converter. There is a name, his name is a grid. So that's why we call it as a bridge circuit, or you can say that, or simply we call it as a grid circuit. And choice of converter configurations for a pulse number, how to choose the pulse number, because there is a some formula will be there, P is equal to something PQRS. So there is a different notation, how many pulses we have to consider for the particular, how many is connected in series, how many is connected in parallel based on your requirement. So all these things analysis will come under this, and then analysis of 12 pulse converter also there. So it is in-depth analysis is 6 pulse converter only. But what we will do is in a 12 pulse converter, we will draw as a diagram 2 6 pulse converters connected in series, and you connect some of the protection circuit, and we'll explain normal 12 pulse converter. But that is not elaborate of with overlap and without overlap. Only grid circuit or a 6 pulse converter will use as a with overlap and without overlap concept. What is meaning of overlap concept here? Anybody? What is the overlap concept here? I mentioned no, in general incoming devices and outgoing devices will not be instantaneous turn off. So there is a, once the firing pulse is given to the circuit, and that particular device is going to be turned on, and immediately the device may not be turned off the particular instant. due to the source inductance or the reason of the load side, that will continue to conduct, but meanwhile another incoming device is fired. This will not be as a turn off completely outgoing device. So incoming and outgoing devices together will fire some duration, that we call it as a overlap period. Now there is a lot of overlap aspects will be there, that is a with overlap analysis and without overlap analysis, and then 2-3 valve conduction, and then 3-4 valve conduction. All the things are come into this picture. And anyhow, so I will explain the next class this introduction further, another units, and then we'll another we can see that start with first unit, and we'll discuss elaborately based on your syllabus. So this is all theory oriented, and some of the problems and analysis is there in the especially for the second unit. And again other units also will be little bit theory, small diagrams will be there, we can able to explain that, and the control strategies, different control parameters, all these things, there is a black diagram also will be there. And you can refer any of the textbook, preferably one textbook is sufficient. There is a KR PDR, you can go through that. And if I have any doubt, you can ask me, otherwise you can give the attendance, your roll number, complete roll number, you can post in a chat box and you can leave. Yeah, 30 members are present. You can give your roll number in a chat box and then you can leave.